Hello, everybody. So, today we will discuss about some of the very basic things that we have been learning through the chapters, chapter number 3 and chapter number 4. So, this is basically CBSE class 9, chapter number 3 and chapter number 4, which deals with atom, the concept, or the discussions between the intellects about how everything around us is made up of matter and what is the structure of the smallest indivisible particle. So atom is, or I would say atom was supposed to be the indivisible particle, okay, for the longest time. But then later on, the discoveries in the 18th, in the 19th and the 20th century led to the understanding that there are subatomic particles, and these subatomic particles constitute an atom. So we have already seen that atom is neutral in nature. So what is the reason for that? Now, the subatomic particles are electrons, protons, and neutrons, out of which the protons and the neutrons are in the nucleus. The electrons are revolving around the nucleus. So it's just like the solar system, where the sun is at the center of the solar system and the planets are revolving around the solar system in specific orbits. So here also in an atom we have a central uh, mass, which is the nucleus, and this nucleus is made up of protons and neutrons. And then you see these electrons, which are the red dots here, which are orbiting or which are revolving around the nucleus, and they are the electrons. Now the electrons are negative in charge, the protons are positive, and the neutrons are neutral. So when it comes to charge, it's only the electrons and the protons who carry the charge. Now in an atom, basically, the number of electrons is equal to the number of protons. So it means that number of minus signs is equal to number of plus signs, or other plus charges. So minus charge is equal to plus charge. In this particular picture here, we are seeing sodium. So it's an atom of sodium. The electronic configuration of sodium is 281, which means the K shell has the K shell has two electrons, the L has 8 electrons, and the M has 1 electron here. Now there are total 11 electrons. Okay, the atomic number also is 11. So 11 protons, 11 electrons, so 11 negative charges, 11 positive charges, it neutralizes. So then the atom becomes neutral. So that is the reason why atom is electrically neutral, because the number of negative charges is equal to the number of positive charges. But does it remain like this forever? Does an atom always Is an atom always neutral? That is another question, which is not so, because we are going to also see formation of ion in this particular session. So where the atom is not neutral, it is charged. Okay, so the conclusion of this particular slide is that atom is neutral. When we come back to the structure of atom, so we just will see something that we have already discussed: subatomic particles, neutron, proton, and electron. This is a carbon atom, and you will see that there are 6 neutrons and 6 protons. So now neutrons, they carry mass but no charge. Proton carry mass and also positive charge. Electron, negligible mass and negative charge. Okay, neutron and proton are in the center, always in the nucleus. So N for neutron, P for proton. The sum of neutron and proton is atomic mass. So the sum of the number of neutrons and the number of protons becomes the atomic mass of that atom. Okay, electrons are not included because electrons have negligible mass, but they have charge. So they electrons are responsible for the chemical properties of an atom always. Whereas protons, they cannot define the chemical properties of an atom, because when a particular atom is participating into a chemical reaction, now the location of the protons is basically in the center of the nucleus. They are never leaving the nucleus, they are tightly bound in the nucleus to the neutrons. So it is the electrons who is actually participating into the chemical reactions, or it is, and that's how you can say that electrons define the chemical properties of an atom, whereas the atomic mass or the neutrons and protons, they are responsible for the physical properties of a particular atom, which is melting point, boiling point. Now in the case of carbon, you're seeing this 6 protons and 6 neutrons are there in the nucleus. If you see the lighter weight or the lighter elements in the periodic table, you will see that number of neutrons, number of protons, and number of electrons are equal to each other. So, like, let us take an example of carbon. The electronic configuration is of carbon is 2 and 4. Okay, 2 and 4. So 2 in the K shell, 4 in the M shell. Now number of protons is 6. Number of neutrons is also 6. So electrons is also 6, protons is also 6, neutrons is also 6. So if you see, they are all equal numbers. But as you move forward and as you come across some heavy metals in the periodic table, you will see that the number of neutrons are not equal to the number of protons. The number of neutrons are higher, somewhere, something like this. This is an example. Okay, if the number of neutrons is 80, you will see that, sorry, the number of protons is 80. Suppose it's a heavy metal, you may find that the number of neutron is not 80, but it could be 100. There is no such element with this kind of a number, but that was an example. So it means that there is a role of neutrons here. And what is the role of neutrons? Neutrons not only add to the mass, because we saw that they do not carry charge, but they have mass. So it's not only the mass that they are adding, but they also bring in stability of the nucleus. How is that possible? Because we know that in a nucleus there are protons. Protons are positively charged. There could be high repulsive forces acting in the nucleus. Okay, if there are only protons in the nucleus, imagine that there are only these positively charged particles which are packed inside the nucleus. They are going to repel each other, and when they repel each other, that could lead to a lot of instability into the atom, and then that could result into the destruction of an atom. So basically, the existence of an atom is questionable if the nucleus itself does not exist. So now, how could you minimize these repulsive forces, or how could you bring down the electrostatic force which is there in the nucleus? By adding or by addition of neutrons. So the neutrons are required say for balancing out the electrostatic forces or the repulsive forces, which are very strong. So we are just talking about carbon here, which is merely only 6 protons. But if you are talking about heavy metals like uranium, we know that they are heavy and they constantly emit radiation. In such a case, these are highly active. Radioisotopes are also there, and they're highly active elements. So in such cases, the number of neutrons is much higher as compared to the protons, because neutrons are offering that kind of stability to the atom, to the nucleus. Okay, isotopes, again, that is also related what we discussed, related to what we discussed just in the previous slide. Isotopes, now we are going to take an example of hydrogen. So the number of neutrons, now what is an isotope? Isotope is same atomic number. What is an atomic number? Atomic number is number of protons in the nucleus. Okay, same atomic number but different number of neutrons, which also means different atomic mass. So in case of, say, protium or deuterium, you'll see that you're just seeing there's one electron there, okay, and in the nucleus you see that there is one proton, which is the plus charge, which is in the nucleus. But in protium, what you see is there is no neutron, so it's only one proton, one electron. And in deuterium, okay, which is the isotope of hydrogen, so here you will see that there is one proton, that is one proton and one neutron in the nucleus. Now if you come to tritium, you will see that there are two neutrons and one proton. So you see that the atomic number, so the number of proton is only one, but the number of neutron is varying. Here there is no neutron, here there is one, and here there is two. So if you look at the mass, it is 1 unified mass, 2 and 3 unified mass. So these are isotopes. So these are of the same element. Actually, isotopes are the same element, but they exist, or they have the same atomic number but different atomic masses, so which is basically different number of neutrons. Now why is it required? I'll give you an example. Now let us move to another example, which is of, say, isobars. Now what are isobars? Isotopes and isobars are different. Isobars have same atomic mass and different atomic number. Okay, these are different elements. These are different elements which have same atomic mass but different atomic number. For example, calcium and argon. Now calcium, the atomic mass of calcium is 40, atomic mass of argon is also 40, atomic number of calcium is 20, atomic number of argon is 18. So we know what is atomic mass: number of protons plus number of neutrons is the atomic mass, which is 40. This is the atomic number. So number of protons is equal to 20. So now based on this, you can calculate the number of neutrons. So n is equal to 40 minus 20 is equal to 20, which is correlating. So it means this is correct. This formula can be used. In case of calcium, you can see that the atomic mass is 40. So equal number of protons are there, 20 protons and 20 neutrons. Now if you look at argon, you'll see that P plus N plus is equal to 40, P plus is equal to 18. So which means that N plus, no sorry, not plus, neutron does not have a charge. I'm very sorry. So neutrons, there are 22 neutrons in argon. So 18 protons and 22 neutrons. So there itself you see that the number of protons is not equal to the number of neutrons. There is a difference of 4. Okay. Now why is this difference there? Why are the number of neutrons more in argon? That's also because when the number of neutrons are more, it is adding to the stability of argon. And argon is a noble gas. So, what are the noble gases? These gases, especially these elements, are those who do not react with any other element. They themselves are very stable, very happy being on their own. They do not want to react with any other element, form any other compound. So, I think there is an indirect answer that why do they attain this kind of noble state? Of course, they have, say, fulfilled duplets and octates in their shells, but along with it, they have a very stable nucleus also, which is a higher number of neutron than as compared to the proton, which is not seen in calcium. Okay, so revising, isotopes and isobars are different. Isotopes are the same elements, okay, but with different atomic mass and same atomic numbers. Isobars are different elements with same atomic mass but different atomic number. So here calcium and argon, I discussed this example where calcium is actually a metal and argon is a non-metal. So you can see that the properties of these are entirely different. These are two different elements. But when we are discussing about the isotopes here, protium, deuterium, tritium, they are all basically hydrogen but with different atomic masses. Okay. Now we come to this formation of ion. This is, I told you that we discussed in the first slide that atom is neutral. But is it neutral forever? So, no, that's because atoms, just like how human beings, we are happy, we want to be happy, we want to shed off, say, our grumpiness, our sadness, and we want to attain happiness. Similarly, every element also wants to be at a ground state. It doesn't want to be always reactive, it doesn't want to be always unstable. So, to achieve that kind of a configuration where it is stable, it has to do some it has to do some losing or it has to do some gaining. What do I mean by that? Now this is sodium. The first one is sodium. The electronic configuration is 2 8 and 1. So in the K shell there are 2 electrons. Okay, in the L shell there are 8 electrons, and in the M shell there is only 1 electron, this one. Okay, now this 1 electron, so the duplet is fulfilled, the K shell is fulfilled, the L is also having 8, which is the octet, that is also fulfilled. But if you look at the M has only 1. According to the Bose and Bury's theory, the outermost orbit, whichever it is, doesn't matter whether it is L, M, N, the outermost shell at least must have at least fulfilled the octet state. But this is not complying by the guidelines of Bohr and Bury. So here it has 1, which means it is falling short of 7. It is falling short of 7 electrons. So now everything is basically transaction of energy here. So if sodium has to become a stable element, it needs to either accept 7 electrons or it has to lose 1 electron. So when you calculate the energy transaction, accepting 7 electrons is going to cost tremendous energy, which sodium cannot afford. But losing of 1 electron may be economical at that point. So sodium prefers to lose an electron. Now in this particular state, there are 11 electrons and 11 protons. Okay, so the charge is neutral. Okay, now 1 electron is lost. So when 1 electron is lost, the configuration now is 2 and 8. So you have 10 electrons because 1 electron is lost. So if you count, you have 1 and 2 here. So you have 10 electrons and 11 protons, which is not an equal number. Here you will see that this number is higher than the number of electrons, which means there's one plus charge balance. So now sodium becomes a positive ion. So an atom that carries a charge, an atom that bears a charge, is known as an ion. Why does it become an ion? Because it loses an electron. and then you'll see that there is an imbalance between the number of electrons and the number of protons. So when the number of electrons is equal to the number of protons, the atom is neutral. When electrons is lesser than protons, the atom becomes a positive ion, and when the electrons is more than the protons, then the atom becomes a negative ion. Okay, that was with sodium. Now let us look at chlorine. So this is chlorine and this is the ion. Okay, the configuration, the chemical the electronic configuration of chlorine is 2, 8 and 7. Okay, so there are in all 17 electrons, and protons is equal to also 17, because we are not discussing heavy elements here, these are on the lighter side. So the number of protons is equal to the number of electrons. So again, in this case, this is going to be a neutral chlorine. Okay, but if you look at the configuration, the K shell is again happy, it's duplet fulfilled. L is also happy, octet fulfilled. But if you look at the outermost orbit is not completely fulfilled. There are 7 electrons. 2, 3, 4, 5, 6, and there are 7 electrons. So according to the Bose-Bury's theory, there has to be 8 electrons. There are only 7. So what would chlorine do to attain stability? It can either accept 7 electrons, it can either lose 7 electrons, or it can accept 1 electron. Again, when you come to the energy costing, the energy that is required, or the energy that chlorine has to really spend to lose 7 electron is much higher than the energy that is required to gain 1 electron. So what is economical for chlorine is to gain 1 electron. So it will gain 1 electron. Okay, so this when 1 electron gets added, you'll see that now it is a happy and stable element or atom, because the configuration now becomes 2, 8 and 8, which is a noble gas configuration, so a noble element configuration. So accepting of electron, what happened when when this chlorine accepted 1 electron? Before accepting the electron, it was a neutral atom, because 17 electron is equal to 17 protons. Fine. But when it accepted 1 electron from, say, some other element, some other atom, it became 18 electron and 17 protons. See, protons number never change. Protons number is always fixed. Why? Because it is in the nucleus, deep down there in the nucleus. It is with the neutrons. It is bound tightly with the neutrons. It cannot leave. Okay, it cannot leave the nucleus and go. So it is the electron which can actually leave, jump, carry charges. So now your electron is increased. So electron number is higher than the proton. So the negative number is higher than the positive number. So chlorine is going to attain a negative charge. So chlorine becomes a negative ion here. Okay. So I hope this was all very easy to understand. If there are any doubts, please leave a comment. Thank you for listening.